Hi everyone. In today's lesson, we're going to graph more ellipses. So today we're going to focus our attention on ellipses that do not have a center at the origin. So let's just draw a picture. I'm going to draw for a horizontal major axis. I'm going to draw the center to be, let's just say here. Here's my center. So what does it look like here? Well, the A value is still the distance from the center to one of the vertices. So this distance here is still A, and we'll call this V2. And then the same distance from the left side, we'll say is about here. This we'll call V1, and that distance there is A. And we'll say B is still the distance from the center to one of the co-vertices. So let's just say the distance from here to here is B, and from here to here is B. This would be called co-vertice 1, and down here would be co-vertice 2. And if you connect this, you will get your horizontal major axis for an ellipse. So this is the picture of what it would look like. Obviously, the foci would still be here and here. They lie on the major axis. So this would be foci or foci 1, foci 2. And they are C units from the center. And that is what our picture would look like. So if I wanted to draw the same picture for an ellipse that has a vertical major axis, we could do that as well. So let's just say I put the center to be here. Now my major axis this time is going to go vertically, so my distance from the center to one of the vertices is A still, and the distance from here to here, the distance from the center to one of the vertices, still A, and then the distance from one of the centers to the co-vertices is B, and our ellipse looks something like this. Now the foci still lie on the major axis, so here we'll call this foci 1, we'll call this foci 2, and they are C units from the center. So that is your picture for an ellipse that has a vertical major axis. Remember, the major axis is the longer axis, right? So this one is my major axis, where the co-vertices are my minor axis. Same thing over here now. My major axis is the vertical. So here's my major axis, and here's my minor axis. So again, key features we talked about. A is the distance from the center to each of the vertices. B is the distance from the center to each of the co-vertices, and C is the distance from the center to each of the foci. The vertices are the endpoints of the major axis. Again, the major axis, that distance is 2 times A. The co-vertices are the endpoints of the minor axis, and again, that distance is 2 times B. And to find the foci, you need to use the formula c squared equals a squared minus b squared. All right, let's look at the equations of these ellipses. So the equation is very similar to that of a circle, where the numerator, x minus h and y minus k, where h comma k is my center. So we can write that down if we'd like. The center for both of these would be h comma k. Now, just as we did yesterday, in order to create a horizontal major axis, the larger number must be first, or in other words, the A value must be bigger than the B value. So A is bigger than B, or when the larger number comes first. Now, to have a vertical major axis, the A value is still greater than the B value, but this time the larger number A will come second, and that's how we get our vertical major axis. So let's take a look at these two equations and see if we can determine some of the key features. So first thing, what type of axis do we have here? Do we have a horizontal or vertical major axis? Well, we're going to look at the denominators. Where's the larger number? Well, 36 is bigger than 25, so since the larger number is first, we will have a horizontal major axis. Now the center is found by negating the signs in here, just like you would a circle. So the -3 turns to a +3, and the +7 turns to a -7. So that would be my center. Now the A is always the square root of the larger number. So if 36 is my larger number, that is your A squared value. And the 25 is my smaller number, so that's my B squared value. So if A squared is 36, we take the square root of 36, and that'll give us 6 for A. And since 25 is B squared, we take the square root of that, and that gives us 5 for B. All right, let's take a look at the second example. So 9 and 4. So the denominator 9 first is bigger. So same scenario, we now have a horizontal major axis. Center is if I negate these values. So -1, +4, just switch them. A is always the square root of the bigger number. So a squared is 9 and b squared is 4. So the square root of 9 gives us 3 and the square root of 4 gives us 2 for our b value. Okay, so now that we know all of that, I think we're actually ready to graph these. All right, so let's take a look. First example, 25 and 9. So 25 is the larger number. So therefore, we're going to have a horizontal major axis. And since 25 is the larger number, we know that that belongs with A, and 9 is the smaller number that belongs to B. So the square root of 25 is 5, that gives me A, and the square root of 9 gives me 3, therefore that's my B value. Again, to find the center, we're just going to negate these values. So -1, +3 will be my center. Now, in order to find the rest of this information, I suggest we graph. So let's start with our center. So our center is at -1, +3. So first things first, let's graph that. Now, since we know that this is a horizontal major axis, it's going to open horizontally. The larger number of 5 means we're going to go 5 to the right, 1, 2, 3, 4, 5 from the center, 5 to the left, and plot our points. We could call this V1 and V2. And now let's count to find our covertices, which are B, 3 up from the center, and 3 down from the center. And we'll call this covertice 1 and covertice 2. And let's connect. Here is my horizontal ellipse. So now that we have all this information, we can go ahead and write down the coordinates of our vertices and our covertices. So it looks like vertice 1 is at -6, 3. Vertice 2 is at 4, 3. So we can go ahead and write that in. So -6, 3, and 4, 3. Our covertices up here and down here are looked to be at -1, 0 and -1, 6. So -1, 0 and -1, 6. And now to find the length of the major axis, we know that the major axis is the distance from one vertice to the other. So this one is my major axis. So obviously if I went from here to here 5 and from here to here 5, if I double that, that gives me 10. And we know that my minor axis is the distance from each of the covertices. So this is my minor. And we know we went up 3 and down 3. Therefore, my distance of my minor axis is 6 if we double that. And now the last thing that we need to find are our foci. So remember, we use the formula c squared equals a squared minus b squared. So our a squared is 25 and our b squared is 9. So 25 minus 9 gives us 16. And we take the square root of that to solve for c, and that gives us 4. So now we have to find where the foci are. Well, we know the foci lie on the major axis, 4 units from the center. So we can go ahead and count 1, 2, 3, 4 from the center. We'll call this foci 2, and 4 from the center on the left side, and we'll call that foci 1. Remember, the distance from each of the foci to the center is c, so from here to here is c. So those coordinates are -5, +3, and +3, +3. So we can go ahead and label that now. So our foci are -5, 3, and 3, 3. All right, so now that we did one example together, I'd actually like you guys to pause the video and try the second example on your own, and then hit resume when you're ready for the answer. Okay, take a look at the answers and jot down any questions that you have, and then ask us in class tomorrow. Have a good night.